Hey everybody, welcome back. Last time we looked at insertion sort, and this time we're going to look at bubble sort. In fact, there will be a challenge here. I want you to write the bubble sort algorithm yourself. I'll start off by describing how the algorithm works to sort a list or an array of numbers, and your task will be to write the pseudocode. We'll then go and implement the pseudocode in two languages, first in C++, then in C#. So let's get started. Now, bubble sort is still a sorting problem, the same problem that insertion sort is used to solve. So I've put this back up on the screen. The sorting problem formal definition: the input is a sequence of numbers and the output is the sequence of numbers in sorted ascending order. And I'm going to use the same input array as we did with insertion sort. Here it is for your reference, 108701. And the way bubble sort works is you have iterations from I equals 0, as you see here, starting with j equals 4 in this case, and 4 being the length of the array minus 1, which gives you the index of the last element. So in this case, we have j there above the number 1 at the end of the array, and whatever is to its left is j minus 1. And in each iteration, you start comparing j with j minus 1. If the number to the left of j, which is j minus 1, is greater than the number j at j, in other words, if the number to the left is greater than the number to the right, then you do a swap. But 1 in this case is greater than 0, so you don't swap. But proceeding in this way, we can see how bubble sort works starting on this screen. So iteration 0, j equals 4, as I showed in the previous screen, 0 and 1 remain fixed, they don't swap. Then you decrement j, so j is now 3, but you're still in iteration I equals 0. You look at 0 and 7 and you swap them because 0 is less than 7. Then you look at 0 and 10 when j equals 2, because you've decremented j again, 0 and 10, and you swap those because, again, 0 is less than 10. And then you get to I equals 0, j equals 1, and you swap that, and you're done with the first iteration, or iteration 0. And you have the current state of the array being 0, 8, 10, 7, 1. Then you increment I. And now you start back at j equals 4. And again, from the end element, you start swapping whenever something to the left is greater. As you can see, the 1 and the 7 will swap. You continue in this way until you get to iteration 1, j equals 2. And then you swap 8 and 1 in that case, and you get 0, 1, 8, 10, 7. Then next, iteration 2, j equals 4 again. You start swapping, you get to where you swap until 2, you're in iteration 2, and j equals 3. And then you're done with that iteration. Finally, you go to iteration 3 and you start with 4, and no swap is needed, so you have the completed sorted output 0, 1, 7, 8, 10. Now that we've described bubble sort, let's go back and look at the ranges that I and j go through. I starts at 0 and goes to 3 in this case, and j always starts at 4 and goes back to whatever I is plus 1. If you notice, we always stop when j is I plus 1 at each iteration. So if you look at iteration 0, we went to j equals 1, and that ended that iteration. When we went to I equals 1, j went all the way to 2, and then we stopped because you don't go beyond that. Otherwise, you're trying to sort with things that are already at the top, or should already be there, like 0 in this case. So we need to range I between 0 and basically the end of the array minus 2. So the length of the array minus 2. And j always ranges between 4 and whatever I is plus 1. So we're going to use that information to design our pseudo code. Let's go do that now. So let's write this algorithm, which we're going to call bubble sort. And it's going to take an array A as input. And remember, we're ranging I as follows. I has to go from 0 to the length of A minus 1. But while it does that, what we want it to do is for the inner loop, say j has to go from the length of a, so it's counting down, minus 1, so the length of a minus 1 to I plus 1. So it's going from the end of the array, essentially, back down to whatever I is plus 1. And every time j iterates, what you want it to do is do a swap. If the jth element is less than the element to its left, or the one just before it, if that is the case, then we want to do a swap. We'll write the swap as follows. Once we implement this, we should be able to use bubble sort to bubble smaller elements to the top, swapping every time a comparison is made and the item to the right is less than the item to the left. So here we are back in CLion. You, of course, may be using a different IDE for C++ programming. Whatever you have, you can use Visual Studio on Windows or some other system. But on Mac, what I've got is CLion. And as I discussed before, this costs money, or you can get the free trial for a certain number of days. But whatever IDE you're using, go ahead and open it and click New Project. C++ 20, I believe, is the latest standard, so you can actually, in CLion, you can choose whichever one you want. I'm going to choose C++ 20. I think you may have seen C++ 23 here. That's not a standard that's being considered, so I wouldn't use that. 20 should be the latest. Then click Create, and it should create some boilerplate code for you right here in a file called main.cpp, which is fine. And let's get started. First thing I'm going to do is delete what's there because we're going to start from scratch. Now in C, in a previous video, we used something like this. In C++, this doesn't exist. You don't write standard io.h, you write iostream. And that's how you declare input-output functionality in C++. Now let's start with the main function. I can say int main. And I'm starting here because this basically outlines the things we're going to do at a very high level in this program. First thing I want to do is create the array that we're going to sort. And next, just as in C, I'm going to need to calculate the size of the array because that's not a function that's readily available in C++. And size of the array will get you the total number of bytes, but you have to divide by the size of any of the elements of the array. Next, I want to bubble sort the array. And so I'm going to create a bubble sort function later that takes in the array as an input and the size of that array. After that, we want to print out the results. I'm going to say standard cout, and this is how you would output something to the console. Then I want to call a function called printArray. Again, we're going to pass the array and its size. And because this returns integer, if everything works well, I want it to return 0. And now we have to go and implement a couple of functions. We need to implement bubble sort, and we need to implement printArray. And right here, I'm going to paste in what we typed earlier in comments, and let's just go ahead and implement it. So void, because this isn't going to return anything, it's just going to sort the array. Bubble sort. And it's going to take an array as input, and it's going to take n, let's say the size of the array, as another input. And if you look at the first line of the comments of bubble sort, we're going to say from I equals 0 to I less than the size of the array minus 1. And for that array, what we're going to do is another for loop for j equal to n minus 1, the length of the array minus 1. And that's going to go down to j greater than I, in other words, j greater than or equal to I plus 1 as it shows in the comments, and every time we iterate, we reduce j by 1. And I forgot here to do I plus plus. Oops, that should be a semicolon. And so next we have, in the pseudo code there, we want to check for a condition. So if array j is less than array j minus 1, what we want to do is swap. And I'm going to create another function for this because I don't want to have to write all the swapping functionality inside bubble sort. So swap, and this is where I'm going to introduce a new concept. As I said before in this series, I like to introduce concepts as we go along. And that's the concept of a pointer and finding the value of the address where a variable is stored. So I could swap array j and array j minus 1. Those are the values of the array. Or I can swap what's in their addresses, where those values are stored in memory. So I can say, or use the ampersand symbol, that's the address of operator in C++, and I'm going to take array j and swap it with whatever's in the address at array j minus 1. This might be a little confusing, but that's okay. I'll explain it a little bit further later, but the point is to keep introducing new concepts, which we may encounter in programming languages and computer programming in general. Now let's go ahead and write the swap method. I'm going to say swap, and here what I'm going to do is something that's also related to pointers, and that's called dereferencing a pointer. If I use the asterisk, and I'm going to say the right value, and then I use another variable called left with an asterisk, what this is saying is that there's, expect an address. Right is the address of a variable, not a variable value itself. The star will then take the value at that address. So I'm going to introduce a temporary variable and set it equal to whatever is in the address at left. And so if you look down at what we passed, that's array j minus 1. And then I'm going to take whatever is in the right and place it in whatever's in the left. So the value in the right gets placed in the value of whatever the address is of left. And then finally, you take what's in the temporary and you assign it to whatever's in right. And there are lots of reasons why you want to use pointers. It's faster in many cases. It may not make a lot of difference in an app like this, but I wanted to introduce you to pointers very quickly here. There's a lot to unpack here. Don't focus on the pointers. Just know that there is a way to access the address of a variable, and there are times when you'd want to do that to make operations a little faster. We want to be able to print the results so we know that we have a sorted array. And then we're going to say for I equals 0, I less than size, I plus plus. What we want to do is print out each element and then a space after each, to space out the numbers after each entry. Standard, end the line, and that basically inserts a new line. Let's see if it works. I'm going to go to run, and if you see down here in the console, the sorted array is 0, 1, 7, 8, 10. It appears to work. So we've implemented the pseudocode here using C++, and we learned a couple things about pointers and dereferencing the value using the star operator. Now we're going to move on and do this same project, bubble sort, in C#. All right, so to implement bubble sort in C#, I'm going to open a new IDE, and this is freely downloadable on either Mac or Windows or even Linux, and it's called Visual Studio Community. Get the free version. I think that's called Community on Windows. I'm not sure if it's called that on Mac, but get Visual Studio, not Visual Studio Code. So you should come to the splash screen shown here, and you want to create a new project. So I'm going to click New. That opens up this dialog box, and I'm going to create a console application. If I click App here, I can actually choose C# or F# here. Don't worry about F#, but I'm going to choose C# console application. Click Next. And you have a target framework. Don't worry about that. 3.1 is fine. Click Next. And then let's call this project Bubble Sort. Its solution name will be called Bubble Sort. And the location is fine, just note where it puts it. I'm going to put mine in a thing called Projects. Make sure this is checked. Create a project directory within the solution directory, and click Create. And now I have the project solution space, and it puts in some starter code for you, which I'm going to delete because we're going to start from scratch. So there we go. I've pasted in comments the pseudocode we had before, and now let's do this in C#. Well, in C#, you have to use the system package for doing console output, so I'm going to say using system. And just like in Java, everything needs to belong in a class. So I'm going to call this class, we'll call it sort bubble, because I'm going to create a function called bubble sort, and I don't want the names to be the same. That wouldn't work in C#. I'm going to, inside, we're going to have a number of functions, and as before, I'm going to start with the main method, and main here is capitalized, as opposed to Java, where it's lowercase. I want to have the input array again, and I'm going to bubble sort, a function we have to create, that array. And I'm not passing the value of the size of the array, because in C# there's a built-in method to find the size of an array. Then console.writeLine will write to the console, and then we want to print array. Notice I use capital letters for the functions because that's the style that C# uses, that is recommended in the style guide. Okay, so we have class sort bubble, we have the steps listed in main that we want to do, so now let's go ahead and implement the algorithm above in the comments in C#. And it takes the array as input, and inside we're going to get the value of the array size, and you can just say array.length, and then for j, if array j is less than array j minus 1. Now here we're going to use pointers again, but you don't have to worry about the two different operators, the asterisks and the ampersand that you had in C++. Instead, in C# you could just say you're using a reference to array j and a reference to array j minus 1. Now we have to go and create the function swap, and then again use reference integer right, let's say the right variable, or the right value, reference integer left. There's a temporary variable that holds a thing on the left, and then we're going to take the thing on the left and assign to it what was on the right, and finally take what's on the right and put what was in the temp. One thing left to implement, and that's printing the array. And we need the length of the array, int I equals 0, I less than n, console.write, and this time we use write because we don't want a new line after every time we print, because we want these horizontally. We just want them printed in a row, and after that's done, console.write line will add a new line. So let's go ahead and run this. I'm going to click you can go to run and click start without debugging, or you can go to this little play icon. It's hard to see, but I have 0, 1, 7, 8, 10, which is the sorted array, and so it appears to be working. So congratulations. To summarize, you've built an algorithm to do bubble sort and implemented it in C++ and C#, two programming languages you haven't seen before if you've been following this video series. This is the power of designing your code first in algorithms. If you didn't know how to write functions in C#, you could just Google functions in C# and very quickly understand how to do that. And all you need to do is implement the algorithm just as it's written up here in that code with its syntax. Okay, congratulations once again. You implemented bubble sort using the algorithm approach where we designed the pseudocode first, and then implemented that pseudocode in C++ and C#, which are languages which you haven't used before if you've been following along in this video series, further demonstrating the power of writing pseudocode first before you implement in code. So we also looked at an IDE we haven't used before, which is Visual Studio, available for free on both Mac and Windows. Now, here's what the algorithm is, the bubble sort algorithm that we developed. But do you see a problem here? Is there a way we can speed this up even more? It's something you should always ask when developing algorithms. So the question is, what if an array you were trying to sort using bubble sort was already sorted? Would there be any way for this thing to short circuit itself by noting that, you know, the arrays are already sorted, we don't need to go through every iteration to sort it again? If you think about it, if you keep track of how many swaps are made on each iteration, and you find out that on a certain iteration no swaps were made, that should tell you that the array is already sorted and you don't need to keep going. And so I will introduce in the next slide here, I'll introduce what you could do. We're not going to code this because I'm confident now that if you wanted to go back, you could code this and create sort of an optimized bubble sort algorithm. So if you look here at do if aj is less than aj minus I, then we do the swap. But you have a variable called swapped, maybe it's a Boolean, and you set it equal to true. That means there was a swap that happened during this iteration through the loop. If in the end of going through that inner for loop using the j variable here, you get swapped as false, in other words, swapped was originally false and it's only true if a swap happened. If you get a false, you just break. You're done. And that indicates that the bubble sort algorithm is finished and the array is already sorted, so you don't need to keep going through and iterating through again. So this is a way to optimize bubble sort and make sure you're not doing unnecessary iterations through a loop. Bubble sort performance is similar to insertion sort. It takes n squared time, which is the size of the array squared, if you think about it in terms of how we've been describing how fast an algorithm works. By the way, n is better than n squared, and n squared is better than n cubed, and so on. And even better than n might be order log n, in other words, the logarithm of n. There are some algorithms that run in order log n time, and we'll get to those in the future. But this is very similar to insertion sort. There are reasons why you would use one over the other, and it might have to do with the size of the array and how well sorted it is to begin with. We're not going to get into all that, but this is something that you can start thinking about. And as a preview, in the next video, we're going to be talking about recursion. And recursion is used as a basis for a lot of other algorithms, and what recursion is where a function repetitively calls itself. We'll get into that in the next video. I'm very excited to talk about it because it can be a confusing topic, but if we break it down using some simple examples, we'll get there. We'll understand something that is high in demand and understanding if you want to become a great programmer or even be hired by some of the leading companies out there. Recursion is something you really need to understand. Can't wait to see you there. Congratulations again. I'll see you next time.